Graphical solution of linear system of equations. For the given system of linear equations, if we draw each equation of the system on the same grid, then the point of intersection of all lines gives solution of the linear system. Here we have a given system of linear equations in two equations with two variables. Let's get started and graph each of the participating equation on the same grid. For this purpose, we will find table of values side by side for each equation. So given equation is x plus 2y equal to 6, and the other equation is given here, 5x minus y equal to 10. So we will be isolating y as first step of the procedure for drawing graph of linear equations. So for this one, we will move all the terms independent of y to the right side of the equation, which will give us minus y equal to minus 5x plus 10, and then minus y times minus 1. If we multiply minus 1 on both sides of the equation, this will give us y equal to 5x minus 10. This is the required form in which y is isolated on one side of the equation, and let's call this as equation 2 and deal with the first equation of the system the same way. Here we have 2y equal to minus x plus 6, and then divide both sides by 2, which will give us y is equal to minus x plus 6 over 2. This gives y in isolated form, y equal to minus 1 by 2x plus 6 over 2, which is equal to 3. This is equation 1 of the system. Now for next step, we will require table of values for both equations, so that we will do side by side as well. For this equation, let's write down x, and the values of x we will choose will be multiples of 2 because 2 is in the denominator. So assuming values of x, we will consider the fact that we don't need to have fractional values of y. That's why we assume only those values of x which are multiples of 2. So let's get 0 here, then 2, then 4, then 6, enough values, and here we will find values for y. At x equal to 0, y is equal to minus 1 by 2 times 0 plus 3. That will give us y equal to 3. So against x equal to 0, we have y equal to 3, and at x equal to 2, y is equal to minus 1 by 2 times 2 plus 3. That will give us 2. Minus 1 plus 3, that will give us 2. So this is 2, and if we do one more, at x equal to 4, y is equal to minus 1 by 2 times 4 plus 3. That will give us 1 because 2 times 2, and this is equal to minus 2 plus 3. This will give us y equal to 1. So we have 1 here, and for 6, if we look at the sequence for every increment of two values in x, there is y is decreasing by 1. Therefore, the next value will be equal to 0. From this, we will have the ordered pairs xy, and ordered pairs of xy will be 0, 3 and 2, 2 and 4, 1 and 6, 0. These will be the ordered pairs for equation 1. Similarly, now we will deal with equation 2, and for second equation we are going to assume couple of values for x, which is the independent variable. So x will have the values equal to 0, 1, 2, 3, 4, 0, 1, 2, 3 and 4. Against these values of x, we will find values for y. So at x equal to 0, what will be value for y? Y is equal to 5 times 0 minus 10, that is equal to minus 10. So for y here, against x equal to 0, y is equal to minus 10, and at x equal to 1, y is equal to 5 times 1 minus 10, that is equal to minus 5. So this would be minus 5. At x equal to 2, y is equal to 5 times 2 minus 10, that is equal to 0. Therefore, for x equal to 2, we have y equal to 0, and we can clearly take a look on the pattern. For every increase of 1 in values of x, y increases by 5. So the next value will be 5 here, and next value will be 10. Minus 10, minus 5, 0, 5 and 10. The ordered pairs we will have for xy would be 0 minus 10, 0 minus 10, and then 1 minus 5, and then 2, 0, and then 3, 5, and then 4, 10. These will be the ordered pairs for the second equation, and we have the first equation on one side, second equation on the other side. If we draw the line dividing data for both equations, now we are going to draw these pair of values, these ordered pairs, on the same grid. So let's draw the grid here, and the grid we will have for x and y will be this. So let's use this grid for drawing the graph of both of these equations. So this is positive y-axis, this is positive x-axis, and now if we draw the first pair of values, which is 0, 3 and 2, 2, 0, 3, 2, 2 and 4, 1. So here this is origin, this is 0, 1, 2 and 3. So this is the point 0, 3, and next point is 2, 2. 2, 2 is a point right here, and 4, 1 is a point right here, and 6, 0 is a point right here. So we have few points. Let's name these points as A, and then B is 2, 2, 2, 2, and then this is 4, 1, and then 6, 0, and name it as point C, and this as point D. And now we can visualize a straight line through these points, and for that purpose we will pick up a line and draw the line through these points. Here, this is the required line. We can extend this line on either side, but for now this is sufficient, and the equation of this line is y equal to minus 1 by 2 x plus 3. Similarly, we will draw the second equation, which is y is equal to 5x minus 10, and for that the first pair of values is 0, minus 10. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, and minus 10. That's the point right here, 0, minus 10, and let's call it A dash. And the next pair of values is 1, minus 5. So 1 is the abscissa, and 1, 2, 3, 4, and 5. This is the point part. 1, minus 5, 1, minus 5, and label it as point B dash. And next is 2, 0. 2, 0 is point right here, and call it as C. 2, 0 are the coordinates. And next is 3, 5. 3, 1, 2. So this is 3, 1, 2, 3, 4, and 5. That's the point right here. And let's call it D dash. And this is 3, 5. Now we have enough points to visualize a straight line through them. Let's draw another straight line through these points, and all these points are on the line. Here, this is the line, and the equation for this line would be y equal to 5x, y equal to 5x minus 10. That's line for this. And this is the point of intersection, which must be a solution. Whenever we draw the graph on graph paper manually, the point is always an approximation, and we can draw a straight line from this point perpendicular to y-axis as well as x-axis to find the coordinates for the point. And for that, what we are going to do is we will be requiring this line here. So let's draw another line here. And this is a good approximation of this point. And here you can see that the value of x means this distance x, and this is y distance. X seems like 2.36, x seems 2.36, and y, the height is 1.8. So the solution, this is approximate solution, so the solution would be, solution is 2.36, 1.8. Whenever we draw the graph manually, the solution is always an approximation. Here, for this given linear system of equation, 2.36 and 1.8 is the required solution of the system.